Today, we will be discussing the graph of y equals sine of x. And the graph of y equals sine of x looks like a wave. Just like the graph of y equals cosine of x. However, there are differences between the graph of sine of x and the graph of cosine of x. So previously, I have made a video on what the graph of y equals cosine of x looks like. This video is about what y equals the sine of x looks like. And in a later video, I will be comparing and contrasting the difference between the graph of y equals sine of x and the graph of y equals cosine of x. So if we take a look at this picture right here, we've got the unit circle with a radius that is exactly 1 unit in terms of length. We also have an angle theta right here. We have 90 degrees, which is the same thing as pi over 2 radians. We have 180 degrees, which is exactly the same thing as pi radians. We have 270 degrees, which is the exact same thing as 3 pi over 2 radians. And last but not least, when the graph makes a full, complete circle and ends back at 0 degrees, which in this particular case, even though 0 degrees and 360 degrees are not exactly the same thing, when the graph makes a full rotational circle, when it arrives at 360 degrees, the pattern and shape of the graph officially repeats itself. Just like how when it started right here at 0 degree. So we know that sine is equal to opposite divided by hypotenuse. So if we take a look at this shape right here, it is a right-angled triangle with the 90-degree right angle right here and an angle theta right here. That is formed by the radius r as well as this portion of the x-axis. Now, given the fact that sine is equal to opposite over hypotenuse, this means that the sine of angle theta would be equal to the opposite side, which is this side right here, from here to here, and divided by the hypotenuse, with the hypotenuse being the radius of the circle, which is from here to here. And the reason why at 0 degrees, which is the same thing as 0 radian, the graph starts at 0 is because when you're here, there's basically no triangle at all. There is a hypotenuse. However, the opposite side, which is from this point to this point, is 0. And 0 divided by anything gives us 0. And for that reason, the graph starts right here at 0, 0. However, as we increase the angle, this opposite side of the right angle triangle gets bigger, 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 and bigger. And for that reason, this increases. And when you reach pi over 2 radians, which is the same thing as 90 degrees, right here, the length of the side of the triangle that is opposite to angle theta is exactly 1 unit long, which is the same as the length of the radius of the circle. And 1 divided by 1 gives us 1. And for that reason, at 90 degrees, which is the same thing as pi over 2 radians, the graph is right here at exactly positive 1, not negative 1, but positive 1. Now, the reason for why at 180 degrees, which is the same thing as pi radians, the graph drops back down to exactly 0 is because if we take a look at this pen carefully, as it rotates from 90 degrees to 180 degrees, this part right here, from here to here, I'm just gonna use this ruler right here. So so from here, this point to this point right here, that would be the side of the right angle triangle that is opposite to angle theta, with angle theta being right here. And as you drop down to here, once again, the side of the right angled triangle that is opposite to angle theta, which is this numerator value right here, opposite, becomes 0. And 0 divided by anything also still gives us 0. That's why at pi radians, you have the value 0 right here. Now, as the rotating arm continues to rotate, we still have the hypotenuse, which is the radius of the circle with a unit of exactly 1 unit in terms of length. However, the side of the triangle, so I'm just going to replace this. Let's suppose I make a drawing right, let's just say right over here, like this. And you have an angle theta right here. But at this point, the side of this right-angled triangle that is exactly opposite to angle theta, which is this part right here, that has a negative y value because it is going down instead of up. So given the fact that the y value is negative, this opposite side is also negative. However, the hypotenuse side is positive, and a negative number divided by a positive number produces a negative number. And so therefore, as the rotating arm continues to rotate, when it reaches this point, which is 270 degrees, which is the same thing as 3 pi over 2 radians, you have negative 1 divided by positive 1, which gives us negative 1. And for that reason, at 270 degrees, the point of the graph is right here at exactly negative 1. Now, as the rotating arm continues to rotate, when it comes back right here at 0 degrees, where the cycle repeats itself. So given the fact that it has made a full circle, even though it came back to 0 degrees, it still made a full circle, which is 360 degrees, as shown right here, which is the exact same thing as 2 pi radians. So when the rotating arm comes back to this position right here, where it started from, once again, the side of the right angled triangle that is opposite to angle theta, which is this part right here. Actually, I'm going to make a separate drawing. So it would be, let's suppose we have this right here. So let's assume the rotating arm is right over here. Now this means that angle theta would be right here. And this also means that the side of the right angled triangle that is exactly and directly opposite of angle theta would be right over here, with the 90 degrees being over here. And as you can see, as the rotating arm approaches the horizontal x-axis, this side of the right angled triangle from this point to this point, which is opposite of angle theta, gets smaller and smaller. And as it touches the horizontal x-axis, it becomes exactly 0. And 0 divided by the hypotenuse, with the hypotenuse being exactly 1 unit long, produces 0, because 0 divided by anything gives us 0. And for that reason, the graph at 360 degrees, which is 2 pi radians, it returns back to 0. And from this point onwards, it continues. The cycle repeats itself. And this is why the graph of y equals sine of x looks like this. And where it starts at 0, it climbs up to pi, it climbs up to 1 at pi over 2 radians. It drops back down to 0 at pi radians. It drops even further to -1 at 3 pi over 2 radians. And last but not least, it climbs back up to 0 at 2 pi radians.